Hi everyone, this is Mr. Richmond, and for this video I'm going to walk you through how to do one example from your nuclear symbol slide on slide number 5 for your most recent ions, isotopes, and nuclear symbol ClassKick assignment. So we've worked a little bit with nuclear symbols. I also have a YouTube tutorial posted up here that goes into a little bit greater detail than what I care to get into for this video. But just know that the atomic number is down below, the mass number, sum of protons and neutrons up top. Top left-hand corner, and then top right-hand corner gives you the overall net charge. So we have a few different pieces of information. We have atomic number 5, which is boron. If I were to look at my periodic table and find atomic number 5, I can confirm that we do have the element boron. Its most common isotope has a rounded mass to 11. So typically we're going to have 11 minus 5, 6 neutrons in our most typical atom of boron, as well as 5 protons. If it does not have 5 protons, it is not boron. So the amount of protons, it's got to be 5. If it doesn't have, just like I said, if it doesn't have 5, excuse me, that was my highlighter. If it doesn't have 5 protons, it is not boron, so it needs to have 5 protons. Neutrons, its mass is 11, so 5 plus what? 5 protons, which is 1 AMU for each proton, so 5 AMU plus how many neutrons, which are also 1 AMU. 5 plus what will get me to 11, or in other words, 11 minus 5 is 6 neutrons. This is where it gets a little bit challenging. I have an overall charge of minus 3. So I'm going to go ahead and I think it might help some of you draw out the actual number of positive and negative charges that you have. You have 1, 2, 3, 4, and 5 protons. To start off with a neutral atom, we have 1, 2, 3, 4, and 5 electrons. However, I'm telling you now that it's no longer neutral. It has a charge of minus 3. So boron would love to achieve its octet to maybe gain 3 electrons. So now to figure out this last column is just as easy as counting the amount of electrons that you have. You have 3 additional electrons, 3 negative charges compared to your protons or positive charges. That is reflected by the overall charge in the top right-hand corner of your nuclear symbol. So I have 1, 2, 3, 4, 5, 6, 7, 8 electrons. I hope this helps for the rest of your examples, and good luck with